Welcome. In this session, we'll solve a few more examples based on this sampling of continuous time signals. So in this session, we'll continue with the examples. Now remember, if x of t suppose is a cos 500 pi t plus b sine 1000 pi t. Sorry, 100 pi t. So let's suppose this is our signal and our goal is to determine the Nyquist rate. Now remember, Nyquist rate is simply given as 2 times the maximum frequency component b if it is in radian hertz, or you can say if you can write the units in radians per second, or you can write the unit also in hertz also. So you can say if the values are given in hertz or radian. So let's the frequency component of the first component here is, meaning the first is, let's say it is 500 omega instead. So omega 1 is 500 pi and omega 2 is 100 pi, right? So which one is higher, omega 1 or omega 2? So omega 1 is higher, so this will decide the Nyquist rate of this. So to obtain the Nyquist rate of this, either you can say Nyquist rate is simply 2 times the maximum frequency component, that is 500 pi, so that is 1000 pi. So this is the, 1000 pi, so this is in radians per second. This is the Nyquist rate in radians per second, or you can follow it using getting the answer in hertz. So you can say from this f1 is omega 1 by 2 pi, omega 1, so this will be 2 pi, and you can see that is 500 divided by 2 is 250 pi, and pi we can say. So f1 maximum frequency component is f1, so Nyquist rate in hertz will be simply 2 times the maximum frequency component, that's 200, so this will be 500 hertz. So this is the answer in hertz. So this is one case. Same way, if the signal is now, suppose some constant time is cos of 500 pi t, this is just an example, and cos or sine, whatever is the product, cos or sine, so it is 200 pi t. So if this is the case, means if these signals are multiplied in time domain, in frequency domain, these will be convolved. Now remember, to get the maximum frequency component will be simply the addition of these frequency components. So FM means the maximum frequency component will be simply addition of F1 and F2 if it's in hertz, or you can say omega m, or we wrote it b in the previous class. We say b will be equal to omega 1 plus omega 2, and this will be in radians per second. So this will be in omega 2 and this is in radians per second. So you can say omega m first will be equal to omega 1 is 500 pi and this is 200 pi. So this is 700 pi. So this is omega. So Fm from this, the maximum frequency component will be simply omega m divided by 2 pi. So you can say omega m is 700 divided by pi, and this is 2 pi. So this will be 350 pi and pi we can say. So you can say the next rate here is, the next frequency will be 350 multiplied by 2, that's 700 hertz. 700 hertz, or simply 700 samples per second, or you can say in radians, you can say Nyquist rate in radians will be simply 2 times this. This will be 2 multiplied by 700, that will be simply 1400 pi radians per second. So this is the sampling rate in radians. So this is the second case. So this is the second case, if the two signals are multiplied with each other. Now the third case you can consider is if the signals are convolved in time domain. If the signals are convolved in time domain, let's take the example of, so if the signals are convolved in time domain. Now remember, in convolution, we take the frequency which is minimum. Now see, you can see the frequency here is 200 pi. Here the frequency is 100 pi. So in terms of hertz, this you can say this is 100, and f2 is 50 here. So it's 50 hertz. Whatever is the minimum of these two, you take that as the maximum frequency. Why are you taking the minimum? I will tell you the answer, but first calculate the Nyquist rate. First, if you want to calculate the Nyquist rate in to compute the Nyquist rate, you will use the minimum frequency. So the minimum is 100 pi. So it will be 2 into 100 pi. So this is 200 pi, but in radians per second. Same way, Nyquist rate that you can compute using the hertz. So this is 2 multiplied by 50 is 100 hertz. So this is hertz. So this is how we compute the Nyquist rate in radians and in hertz. Now, why do we say that it is the minimum frequency in convolution? Now, remember, if, let me take the example of x of t and x of 2t. Now, why is this minimum for these two? Now, when you convolve the signals in time domain, remember in frequency domain, they get multiplied. So if this is the spectrum, if the spectrum of this looks like this, so this is f1 to f1 minus f1 to f2, and you are multiplying this with, in time domain, they are convolved, means in frequency domain, these will be this. So this is f2 minus f2. So when you multiply these two, you will be left with the signal portion which has the minimum duration in frequency domain. That's why in frequency domain we selected a minimum frequency, not the maximum frequency. So if two signals are convolved in time domain, the frequency that you will select for Nyquist rate will be the minimum one. So if you multiply these two, for example, if I take the example of this, although the spectrum for these two is different, completely different. So let me take an example. Let's suppose one signal has spectrum varying from minus 50 to 50, and another signal has varying spectrum from 100 to 100. This is just an example, 100 and 100. So when you multiply these two, what will be left to? So suppose this is 2, this is 1. So the output will be simply the spectrum 2, but from minus 50 to 50. So the spectrum, means the maximum frequency component, will vary from minus 50 to 50. That's why we selected the minimum frequency, not the maximum frequency in convolution operation. All right, let me end it here. I hope you understood. These are very important for gate examination. Let me end it here. In the next session, we'll start with the Z transform operation.